my name is Micah Oeur. I graduated from Cal State Long Beach in 2020 with a BS in physics, and now I'm doing my PhD in astrophysics at UC Merced. And I'm so happy to talk to you about my research today. If you have ever looked up at the night sky and wondered about our cosmic origin story, you're not alone. In fact, we are made up of the same material as stars and gas, visible matter. But in the total mass budget of the universe, the largest slice of the pie at 85% is actually an invisible material called dark matter. And dark matter interacts through gravity, which is an attractive force that pulls the visible material together, condensing it down into galaxies like our own home, the Milky Way, ultimately supporting all life forms that exist, including ourselves. So dark matter is the primary driver of structure in our universe, and it should raise some alarms that we know very little about it. To improve our understanding of the fundamental nature of this mysterious, invisible substance that we cannot directly detect by aiming a telescope up at the sky, my work focuses instead on measuring what we can see. So I'm exploring a new exciting tool in astronomy called orbital torus imaging to estimate the distribution of matter in Milky Way-like galaxies. I work with simulations that realistically model interactions between and inside of galaxies in order to test how reliably this novel method performs. We know the ground truths of the simulation, and so we can contextualize the accuracy of this method in very realistic scenarios. So orbital torus imaging relies on two primary quantities to estimate the galactic mass distribution. One, the chemical content of a star, and two, how that star moves through space. And this is important because traditional methods don't readily include stellar chemistry, but thanks to recent telescope data, we now have a vast wealth of information, including chemistry, to draw from. Moreover, this new data shows us that our galaxy undergoes constant change. There is ample evidence that we do not live in an isolated, unperturbed environment. For example, we are neighbored by a galaxy that is roughly a tenth of the size of our galaxy that is actively plummeting into our disk and causing these warps and ripples, sort of like a rock being tossed into water. And this state of constant change is not something that is readily taken into account by existing methods, resulting in mass distribution estimates that are up to 50% off. And so today we find ourselves at a really critical juncture to leverage extensive data sets and obtain more precise measurements of the visible matter distribution, ultimately honing in on the dark matter distribution. This powerful new tool holds promise to revolutionize our view of the universe and to deepen our understanding of the structures that gave rise to everything that we know.